everyone. My name is Swan Singh. Currently, I am pursuing MCA from Kite Group of Institute, Ghaziabad. Today, I am here to deliver a presentation of file system, which is topic of mobile computing. What is CODA? The full form of CODA is constant data availability. It is distributed file system that offers replications. Uh, it replicates on server or create a cache on client and let us make the change to the cache. Its features are open source, server applications, high performance, robust, scalable, security. Uh, CODA file system. It is a network file system and recent of the a descendant of the Andrew file system version 2. It was designed to be highly secure, available, transparent to its user. Andrew file system architecture of CODA is based on Andrew file system. AFS was developed at Carnegie Mellon University. It was designed to support the CMU community that meant servicing workstations. Limitations of AFS. Limitations limited from our replication post-scaling problem, non-availability of service when server and network components fail, no catering for mobile users of portable computer. CODA is designed to overcome the problem associated with AFS. So how does CODA work? It works by implementing two complementary functionalities. First is availability of files by replicating a file volume across many servers. The second one is provide disconnected modes of operation by caching files at the client machine. The CODA architecture means AFS architecture. The CODA architecture is based on AFS, the Andrew file system. The AFS divided into two nodes, two type of nodes. One is voice node, which is dedicated file servers. Second one is virtue nodes, which is client machine, as you can see in this image. The internal organization of a virtual workstation. There are mainly two parts. One is venue. Uh, every virtual station hosts a user level process called venue. And the second one is VFS, virtual file system, intercepts the call from the client application to the user process and forward them either to the local file and system or venue. As you can see in the image, the virtual client machine uh, communicate with the local OS throughout the network by the use of venue process, user process, and all. How the communication works in this means how the server and the client communication in CODA through procedure calls. As you can see, the client send the RPM call to the file server. Then the file server reply to the client. The server keeps sending back the message to the client that it is still working, no problems. If the server dies and the client notices that it is not receiving any message, it report back from for to the client applications. So in this image, you can see how the file server sends file to the updated file to the clients. When a server notice update in a file system, it must not confirm the client which are searching a copy of its to invalidate that copy. There are two ways to invalidate a file. This image can show you sending invalid message to one at a time. method is insufficient as a client may crash before giving a reply to the server. Uh, yeah, now you can see a better approach in the right side of the image, sending invalidation message in a parallel, where the client, server, and all send parallel message together. RPC2. Coda uses RPC2 more sophisticated than the traditional RPC used by NFC. RPC2 implements a functionality called side effect. A separate connection is opened when a remote procedure is called. This separate connection is for the application specific protocol between the client and the server. Here, the side effect in Coda's RPC2 system, where client application and server how they can communicate with each other through stubs to a skeleton and client side effect to server side effect. Now, now naming. Coda uses naming space implementation analogs to the that of Unix. Volumes or building units of the entire file system are mounted at a mount point. Client in Coda having access to the single share namespace. So here is client A, which is going to communicate with the server, and server B is going to communicate with the client B, as you can see in this image throughout the network. So file identifiers, the implementation and resolution of Coda file. Here you can see all the file servers, volume replicated database, file handling, servers, everything, how the file identification and sharing occurs. Coda objective in mobile computing, disconnect operation from mobile computing, failures resilience, performance and scalability security, well-defined cinematic for sharing freely available source code, working of Coda. So here is the image where the application program communicate with the kernel. The kernel will communicate with the venue. The venue communicate with client disk, server, and kernel, all of three. Hoarding, mobile support. Prefetching mechanism in Coda. It client is connected to a server holding prefetch file currently used. As soon as the client is disconnected, application work on replications and goes to emulating state. After reconnecting Coda compared to the replication with file on server, if Coda notice that two different users have changed file, reintegrating fail and Coda save change file up as a copy on server to allow manual reintegration. So how the hoarding working? So you can see how the hoarding is communicating with evaluating and connection, and how it is connected and disconnected. How the right disconnected is correct connecting to the holding a strong connection and holding a connected weak connection to the right disconnected. How evaluating is disconnected and connected to the right disconnection. That's all. Thank you from my side.